Alright, welcome to the tutorial on using the Instron testing machine, our universal testing machine. If you have not done so already, please go ahead and watch the tutorial on how to use the Instron to do tension testing. This will give you a basic rundown on some of the features and how to set up the Instron with the testing with your computer and getting that all set up. So please watch that video for those details and those safety tips as well. Now we're going to cover some material that is specific to 3-point bend testing. And so, as you can see here, we'll zoom into our Instron. The main difference is we now have a different testing apparatus for our system, where we now have the two parts for our system. So we have one head, and then we have two supports. What's going to happen is we'll put our specimen inside of our system, and then the head will press down and put our specimen into 3-point bending. So we'll be pressing it and bending it like so, and then the load cell will measure that bending. And so an important difference with 3-point bending versus our tension testing is that our head will be going down. And so there's some additional risks and hazards with this for the equipment and for you and your specimens. And so do be cautious with this with 3-point bending testing. All right, with that being said, we're ready to start getting set up. In this case, we'll start out by first going over to our computer and looking for the appropriate files. And so you can look at your directions for additional information here. Now for 3-point bending testing, we're going to be using the same software. However, this time we want to make sure that we're using the correct method. And so we can see in our recent methods list that we're going to see now, we can see there's two options here. We have a engineering 314 rectangular section .im_flex, and then we also have one that is a circular section with the im_flex. The important part is that the end of this file name and the test type, they're both flexural method testings. All right. The only difference between the two, one is for a rectangular cross-section, the other is for a circular cross-section. Since we'll be testing a piece of acrylic, we'll go ahead and use our circular section. And you can see that over here in the method description, it is a 3-point bending test. So we'll select it. And then just like before, name your sample with an appropriate name, and then follow along with the tutorials. Next, the support span is going to be set to 2 inches, as that is the distance between the two supports on our system. As we can see that the distance between our two supports is just about 2 inches. You can go ahead and hit next. For the material, please pick the correct material and then set the diameter appropriately after you measure your specimen with some calipers. Alrighty, now the software is ready to go to record our system. We'll go ahead and transition back over to the Instron. Now that we're ready to load our specimen, we need to make sure that it can fit. One thing to check is that sometimes this might not be high enough, and so you're not actually able to put your specimen into the system. What we're now going to use that you haven't previously used are the jog and find position buttons in order to move our system up and down. So I'll go ahead and zoom in on those. In particular, we're going to be focusing on the find position. You should not have to use these two soft buttons. If you use these, they will make large motions. This will be a large jog, and so this will take the system to quickly go up or quickly go down. And so you should not have to use either of these buttons. You should be able to use the find position in order to make your changes, and just with a little bit of patience, you can move your system far. You can move the head up and down far enough. Alrighty. Going back to our system, we can see that our specimen cannot fit in currently. And so what we're going to have to do is we can slowly raise the head by taking our fine position and increasing it. As we can see, as we go up, we eventually are able to fit our specimen into the slot. Alright, now you can see that I am able to freely move around my specimen, and there's actually no force holding it in place. Well, that's actually a bit of an issue for the 3-point bending test, and so what we want to do is we want to put a very small initial preload onto our specimen, so that way it doesn't move, but also so that way the sensor can work properly. So we'll go ahead and put it in, or before we put it in, make sure that you go ahead and look at your load, and we're going to want to balance our load just like we have before. Balance load, then we return. We can now see that our load is essentially zeroed out. Well, now go ahead and put our specimen in, and what we want to do is very slowly bring the head down using the fine position in order to, until it just barely pinches our specimen. The way that I like to do this is to gently move your specimen back and forth, and then once you feel the head grasp your specimen, and you can feel some friction, and that's a good sign that you have a little bit of a preload. And so now, alright, there we go. I can feel it. And there's two ways that you can check this usually. One is physically, where you can feel a little bit of a load. There's a little bit of friction in the system, a little bit of resistance. And then the second way is that you can also look at your force sensor, and where we can see that we now have a non-zero load on our system. Now, make sure that you don't zero out this load, as it is real. It is actually squeezing our system. Okay? What you can do is you can zero out your extension. Oops. By resetting your gauge length. And now you have zero displacement. Okay? Alright. Now that we've set up our system, go ahead and look for the plastic guard, and you can put that in front of our system. And what this will do is this will prevent the specimen, when it eventually breaks, from from bouncing out to us, and it will push it back that way, so that way we don't get hurt by a flying piece of plastic or metal or glass or anything like that. So this will help just keep us safe. Once you're done that, you're ready to go, and you can start your run. You can then see the updates on the computer and or on your display screen. After you hit run, you'll be able to see some updates, and your computer will keep track of your load versus the extension. This time the extension is in the downwards direction. We'll continue our system, and as you can see, your piece will start to bend, and it will eventually break. Alrighty. After it is broken, you'll see that the stop button, that the light for test stopped, has been lit up, and your test is now stopped. And you'll see that you no longer have a load, and your extension is now zeroed out. Since your piece is already broken, you can go ahead and return your system. So to do that, you'll press the return button. And as you can see, that raised our head back to that initial gauge length that we had before. Okay? Alrighty. With that being said, we've now done our first specimen. You can then take down the guard and clean up your pieces. If you have used glass or some other potentially sharp material, do be careful cleaning that up. Otherwise, you are good to go with testing the rest of your specimens. Do let a TA or the instructor know if you have any additional questions. Good luck.